Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 8-1 Extra Practice Number 1 solutions on arithmetic sequences and series. On this problem, we're trying to find the 28th term of a sequence whose first term is negative 35 and second term is negative 55. So to start this off, I'll write the nth term formula for an arithmetic sequence. That's a sub n equals a1 plus d times n minus 1. And the d in this case, the common difference, that's what I have to add to get the next number in the sequence. Well, if I'm going from negative 35 to negative 55, negative 55 minus negative 35 or plus 35 means we have to add negative 20 to keep going forward in this series, this sequence. And then let's plug it all in. So we can say a sub n, or a sub 28 in this case, is going to be negative 35, that's a sub 1, minus our common difference of 20 times, well, if we want the 28th term, we have to plug in 28 for n, and then we're subtracting 1. So let me just go ahead and do that on the calculator. So plugging all that in, we end up with a final answer of negative 575. For this one, we want the 21st term of a series, an arithmetic sequence, that has the first term negative 19 and second term negative 15. So let's use our nth term formula. A sub n equals a1 plus d times n minus 1. The common difference, I can get that by doing a2 minus a1, just subtract a term from the term that comes right after it. So negative 15 minus negative 19, or plus 19, gives us a common difference of 4. That's what I have to add each time to get the next term. Plugging all of it in, we've got negative 19 plus my common difference of 4, and then n is going to be 21, and then we'll be subtracting 1 inside there. So I could use the calculator, but this looks like I could do it without a calculator. This is really 4 times 20, which is 80. Negative 19 plus that is going to give me 61. On this problem, we want the sum of an arithmetic series that has 15 terms, so the 15th sum. And then we're starting with 50, and the 15th term is 190. So I'll start with my general formula for the sum of an arithmetic series. That's n times a1 plus a sub n all over 2. So basically, you're averaging the first and the last term together and then multiplying by the number of terms. So n in this case is 15. There's 15 terms. We're doing 50 plus 190 in there. And 50 and 190, if you add those, that's going to be 240. Divided by 2 is 120. Times 15, well, that's like 15 times 12 with another 0 after it. So that would be 1,800. On this one, we're trying to find the sum of an arithmetic series with 11 terms, starting at negative 1 and ending at 89. So we'll use our sum formula, n times a1 plus an over 2. So n in this case, that's the number of terms, which is 11. a1 is going to be negative 1. an, that's the last term, which is 89. So negative 1 plus 89, that's going to be 88. Dividing that by 2, that's going to be 44 times 11. What's 11 times 44? Well, 10 times 44 would be 440, plus another 44 would be 484. To do this problem, we're trying to figure out the sum of the first 20 terms of a series that starts with 12 plus 22 plus 32. So I'm going to start with my formula, n times a1 plus an over 2. I don't have everything I need for this formula, but it at least kind of gives me a shopping list of things that I need to find before I can get my answer. So I need the number of terms. That's going to be 20. They told us this is a partial sum with 20 terms. a1, that's the first term. That's 12. We've got that. A sub n, we don't know. They said dot, dot, dot over here, so we don't know what our 20th term is going to be. But we can figure it out using the nth term formula. So let me do a1, which is 12, plus we have a common difference of, let's see, 22 minus 12 is 10. And so we've got 12 plus common difference of 10, and n in this case is 20, so 20 minus 1. So let's see here. This is going to be 19 times 10 is 190, plus 12 is 202. So that is our last term of this series. Putting that in our formula here, we had 20 terms times an a1 of 12 plus a20 of 202 all over 2. So this is going to be, let's see here, 214 divided by 2, which is 107. Double that, you've got 2,140 if you multiply that by 20. There we are. But you could use a calculator if you needed to. On this one, to figure out the sum of a series with 17 terms that starts at 6 and goes up like this, I'm going to start with my general sum formula, n times a1 plus an over 2. And I know my n value, that's going to be 17 terms. A sub 1, they gave us that, that's 6, the first term. A sub n, that's the 17th term in this problem. We don't know that yet. So I'm going to use my nth term formula, which is right here, to figure out that 17th term. So we have an a1 value of 6 for this formula down here. For our common difference d, 9 minus 6 gives us a common difference of 3. And n in this case is 17. We want the 17th term. 17 minus 1, that's 16, times 3 is 48, plus 6 is 54. So there's our 17th term. Plugging that back in now to the original formula, we had n value of 17 times an a1 of 6 plus an a sub n of 54 all over 2. And this is going to be, let's see, 60 divided by 2 is 30. 30 times 17, well, 3 times 17 would be 51. So this is going to be 510 then. On this one, we're trying to find the sum of the arithmetic series that begins with negative 24 and ends with negative 96 and a whole bunch of terms in between. So let me start with my general formula, n times a1 plus an over 2. Now, in terms of what I already have, I know the first term, that's negative 24. Last term, a sub n is negative 96, but I don't know how many of these terms there are. So to figure that out, I am actually going to use the nth term formula again. So a1 plus d times n minus 1. But the key here is that we have the other side of this equation as well, a sub n. So this allows you to solve for anything as long as you know 3 out of the 4 unknowns. In this case, we know a1, an, and we can find the common difference based on what they gave us. Using all that, we can figure out what the value of n should be. So for a1, again, I have negative 24. A sub n here, that's going to be negative 96. Common difference, negative 30 minus negative 24 or plus 24 is going to be negative 6. So plugging all that in, negative 96 equals negative 24 minus 6 times n minus 1. Now we just have to solve for n. So I'm going to distribute the negative 6 here. That's a negative 6n plus 6, which when I add with the negative 24 gives me negative 18. And then if I add 18 over here, that's going to be, let's see, negative 78. And then if I divide that by negative 6, well, let's see, 6 goes 12 times into 72, so it goes 13 times into 78. So now I actually have to go back and plug that into the formula here. Don't forget to actually finish the problem. So we have 13 times negative 24 minus 96 all over 2. This is, let's see here, negative 120 over 2 is going to be negative 60. 6 times 13 is 78, so negative 60 times that is going to be negative 780. For this problem, we're trying to find the series sum for this arithmetic series. So let's see here. Let me use my general formula. We've got n times a1 plus an all over 2. I don't know how many terms there are. They actually didn't tell me that. But I do know the first term is 19 and the nth term is going to be 411. But we don't know what n is. So let me use the nth term formula to figure that out. So that's a1 plus d times n minus 1. All of that equals a sub n. Now we know a sub n is actually 411. That's the last term. A1 is 19. The common difference, d, that's going to be 27 minus 19, which is 8. So that'll help us solve for this missing n value, which is the same n value in this sum formula up here. So distributing my 8, I've got 8n minus 8. 19 minus 8 is 11. If I subtract 11, I've got 400 on the left side. Divided by 8, that's going to be 50. So let me go ahead and plug 50 back into this formula along with 19 and 411 for A1 and AN. So this is going to be 430 divided by 2. And I'm actually going to use the calculator for this. So plugging all that in on the calculator using Francie fraction, we end up with 10,750 for the sum of that series.